And hello again. I actually haven't gone anywhere. I'm actually recording these videos one after the other, hence why I'm wearing the same t-shirt and everything. But instead of making one long 40-minute video, just break it down. Partial fractions, part 3, improper algebraic fractions. Check it out. So, what do I mean by improper algebraic fractions? What I mean by improper algebraic fractions is when the highest power of the variable in the numerator is equal or greater, so equal or greater to the highest power of the variable in the denominator. The power of x here, the index is 1, in the denominator is also 1, so I've got an improper algebraic fraction. Now, think about it. If I was to do the polynomial division, 2x divided by x will give me an integer, right? It'll be 2x divided by x. So, I'm not saying that 2 is going to be my answer, but what I'm saying is that when I write these as partial fractions, I'm going to get an integer as a solution plus the remainder, which is that, if you remember your division of polynomials from pure 1. So there I am. Those are my partial fractions. There you go. Common denominator, substitute values, blah, blah, blah. Easy. So, if that is the same as that, 2x over x plus 1 is going to equal a times x plus 1 plus b over x plus 1, right? Common denominators cancel out. 2x equals a x plus 1 plus b, and remember, that's what I call my star equation for some reason, I don't know. I just made that up 2 videos ago. Right, and remember, we're just going to substitute values of x in there in order to find the values of a and b. Which value of x are we going to choose to substitute? We're just going to choose -1 because it would make that bracket 0. So when x is -1, if I substitute it in here, I get -2 equals b. So straight away, b is -2. b is -2. Alright, cool. Now let's substitute what happens when x is 0. So when x is 0, I get that 0 equals a plus b, but b is -2. So a is 2. Done. Sorted. Easy. That's it. Okay. Unfortunately for you, that is the easiest example that you could have come up with. So I'm just going to do one more, and then we'll call it a day, and that will be the whole chapter 2 done. Right, are you ready? Are you ready? Here we go. I've got 3 x cubed over x minus 1, x minus 2, x plus 2. Make sure we copy the example correctly, otherwise life will get very complicated. Right, now, what's that going to equal to? It's going to equal some partial fractions, but what are they going to look like? Let's think. Is this an improper algebraic fraction? Yes. Why? Because the highest power of the numerator is higher, is equal or higher, but in this case is higher than the highest power in the denominator. So the question is, what's the highest power in the denominator for the variable x? Don't say 1, it's actually 2. Why is it 2? Because when I expand the double bracket, I'm going to get an x squared term. Right? So, What do I get if I divide 3x cubed by an x squared? Well, I'm going to get a term in x, aren't I? So this is going to be ax plus b. The b comes from, so when, think about the polynomial division. X cubed divided by x squared is going to give me an x. Then the x squared divided by the x squared is going to give me an integer. And then I am going to get my remainder. And that remainder is going to be c over x minus 1 plus d over x plus 2. Okay, this is just checking that I got the signs correctly. All right, yeah, that's just going to be, this is going to be it, isn't it? Right, so what now? Same old. Add all the fractions on the right hand side of the equation, get rid of the common denominator, substitute values, the usual stuff. So 3x cubed over x minus 1 x plus 2 is going to equal, we're going to take these together, okay, because both of those are over 1, so we just treat them as one single term. So this is ax plus b times x minus 1 x plus 2 plus c times x plus 2 plus d x minus 1, getting long, over the common denominator x minus 1 x plus 2, common denominators cancel out, 3x cubed is going to equal ax plus b times x minus 1 x plus 2 plus c x plus 2 plus d x minus 1. Good old star fraction. Right, same old. Start choosing values of x to substitute in. Well, the ones that are going to make the brackets disappear, so I'm going to choose x equals 1. So when x equals 1, 1 cubed is 1 times 3 is 3. That makes all of this 0. That makes all of that 0. So I get 3c. Therefore, c equals 1. So now I've got c. All right. Cool. Next one. Minus 2. When x equals minus 2, minus 2 cubed is minus 8. Minus 8 times 3 is minus 24 equals, that goes to 0, that goes to 0, minus 3d, so d equals 8. So I've got c and d now, and then the next question is going to be, what are we going to do now? And what we're going to do now is be a little bit clever here, because I can figure out A by visual inspection. The only way I'm going to get an x cubed term on the right hand side is when I multiply ax times x and times x, isn't it? Because if I do ax times x times 2, that gives me an x squared term. These terms here don't give me an x cubed term. So just from looking at it, literally visual inspection, I can see that a has to be 3. The only way ax times x times x is going to be 3x cubed is if a is 3. So a equals 3. And now I've got C, D and A. To find B, we're just going to pick a value and substitute it in. And the easiest value to substitute in, once we've got A, C and D, is x equals 0. So if I substitute x equals 0, 0 cubed times 3, 0 equals 8 times 0 is 0, so I get B minus 1 times 2 is minus 2 times B, so I get minus 2B. All of these is minus 2B. Go through the algebra. X is 0, so that becomes a 0. This is a minus 1 times a 2 is a minus 2 times B minus 2B. 0 plus 2 is 2. 2 times C is 2, so plus 2. And then here, minus 1 times 8 is minus 8. We just solved that simple equation there. And what do we get? Minus 3. We get B is minus 3. And that's it. I'm done. I have finished. Those are the answers. Good. Let's check it out. Go through it. See what happens. Let me know if there are any problems. Bye.